So here we go. We're going to go ahead and go through mixed revision chapter 4. So first we're going to start with question number 1, divide mentally. Okay. So in order to do this, we can see how many times does 7 go into 0? It's going to be 0 times. 7 goes into 49. That's going to be 7 times, right? And so I only need to put a 7 there because 7 times 70 is going to be 490. And then finally, 7 goes into 7,000 one time. So mentally, that'd be 1,070. Okay, let's look at here. 2 goes into 0, 0 times. 2 goes into, 30. Oh, okay, so how many times does 2 go into 30 instead? 2 goes into 30 15 times. There we go. And then 2 goes into the 0, 100, 0 times, and 2 goes into, 2 goes into 50 though. 2 goes into 50, how many times? 25. Great, and so 2,515. Great, okay, and so for this one, we have 6 goes into 6 one time. 6 goes into 40. Ooh, can we do that one? No, we can't. Can we do 6 goes into 540? Yeah, absolutely, because it's going to be 6 times 100 would be 600, right? Minus 10, so that's going to be 6 times 90. Oh, yeah, see? And how we could do that was we could say 6 goes into 0, 0 times, and then 6 goes into 54. How many times? And that would be 9 times, right? Great, okay, now we're doing solve the equations. Okay, so if we have the number 83,493 minus y is just a variable, some number, is equal to 21,390. How we can solve for y is, we don't want 83,493 minus y. Ooh, this is going to be a little bit tricky. The reason is because we can't, I guess we could do minus 83,493. The problem is what would happen is if we did minus 83,493, what would happen is this would cancel out, but on this side, we'd have a negative y. And so this is what we're going to do instead. We're going to add y to both sides. Add y to both sides.
3 and 490.
Sorry, it'll be the same answer if you did it correctly. So we're going to add y to both sides. And so on this side, if we have the minus y plus y, that's going to cancel out. So we have 83,493. And then on the other side, we're going to have 21,390 plus y. And we know how to get rid of it now, right? So now what do we do?
Divide it?
How do we get rid of this y? Or this 21,390 plus y? Subtract what?
21,390.
Exactly. So we're going to subtract it from both sides. Okay, so we subtract it from this side. 3 minus 0 is 3. 9 minus 9 is 0. 4 minus 3, 1. 3 minus 1, 2. 8 minus 2, 6. There we go. And our answer is y equals 62,103.
How do I just do 83,493 subtract 21,390?
No, we can't. And the reason is because if we just subtract 21,390 on this side and 21,390 on this side, that's just going to be, it's going to be like 62 some thousand, right? Minus y. And so that's a little bit weird. I mean, we could do 62,000 something minus y and then add y to both sides, and that would get our answer.
83,493 subtract 21,390.
Did you get the correct answer?
And I got the right answer.
Then you're fine. So you don't have to ask. If you get the right answer, you're good. So just follow these steps if this is the normal way. Okay, I don't want to take questions right now. Remember, students. So we have 20 times s equals 6,340. So 20 times s is 6,340. Okay, and so we don't want the number to be 20 times bigger than SE. On this side, this number, whatever number's on this side, which is 6,340, whatever number's on this side is 20 times bigger than we want. And so we don't want it to be 20 times bigger. So how do we get rid of that 20 times bigger?
Divided by 5.
Ooh, no, not 5. This is an S. This is the variable S, see? This is an S in the example. So we're going to divide by 20 on both sides. Divide by 20 because we don't want to know what 20 times bigger than S is. We want to know what just S is. So by dividing both sides by 20, we get rid of the times 20 on this side. And then we have to find out what this is. So how can we figure out what 6,340 divided by 20 is? Can we
just divide 634 divided by 2 and add the 0 at the end.
Exactly. 634 divided by 2 and add the 0. And 634 is a even number, so it should be pretty easy for us to divide it. 300, and that's going to be 15 and a 2. That's going to be 17 with a 0 at the end. Wait a second. Is there going to be a 0 there? That doesn't make much sense. There we go. We can check our math, right? 317 times 20. Just because we're doing it mentally, sometimes it's good to check. 2 times 7 is 14. 2 times 1 plus 1 is 3. 2 times 3 is 6. Oh, good. See? Great. And our math is correct. So 317. So we just get S is equal to 317. With no comma. Why is there a comma there? Boop. Okay, great. So next we have 3. Solve in the right order. You can enclose the operation to be done in a bubble. Okay, so you see we're going to be listening to PEMDAS here, right? And so remember for PEMDAS, we do multiply and divide at the same time, and we do add and subtract at the same time. And we do it all left to right. So first we're going to do parentheses. Are there any parentheses in this? Yep, 6 plus 9. So we could do the rest of PEMDAS. Are there any exponents in 6 plus 9? No. Are there multiply and divide in 6 plus 9? No. Is there add and subtract in 6 plus 9? Yes, and that's going to turn to 15. And then we're left with 5 plus 15 divided by 3. Are there any exponents? No. Can we multiply or divide? Yes. 15 divided by 3 is going to be 5. And so we're left with 5 plus 5. Can we multiply or divide? No. Can we add or subtract? Yes, and that would be a 10. So everyone make sure that you are getting these correct answers on your practice. So we have, for this one, we have 20 times 12 divided by 3 minus 50. Is there any parentheses? No. So we don't need to do that. Are there any exponents? No. Can we multiply or divide? Yes, we're going to multiply and divide left to right. So 20 times 12, we could do that in our head, 240. So we have 240 divided by 3 minus 50. There's still no parenthesis or exponent. Can we multiply or divide? Yes, 240 divided by 3. We could just do 24 divided by 3, right? And then add the 0. And so that's going to be, what, 8? 8, 16, 24. Yep. So 80 minus 50. And so can we multiply or divide? Nope. Can we add or subtract? Yes, 80 minus 50 is 30. Right? You guys get that? Okay, next we have 100 minus 36 divided by 6 times 7. So first we're going to do parenthesis, no parenthesis, exponents, no exponents, multiply or divide. Remember, we're going left to right. This, nope, 100 minus 36 is not multiply or divide, but this is 36 divided by 6, and so that's going to be, what, 6? So we have 100 minus 6 times 7, and so can we multiply or divide? Yes, we can. Here, 6 times 7, that's going to be 42, right? So I can erase that and write 42. And then, no parenthesis, no exponent, no multiply or divide. Can we add or subtract? Yes, 100 minus 42, that's going to be 58. You guys getting these right? Give me a thumbs up if you're getting them right. Great, okay, next we have parenthesis, 88 minus 3 times 5, closing parenthesis times 2. So, do we have parenthesis? Yes, so we're just going to do the parenthesis and do the rest of PEMDAS in here. Do we have any exponents? No. Can we multiply or divide? Yes, 3 times 5 is going to be 15, so we have in the parenthesis, we have 88 minus 15 parenthesis times 2. So you guys see I'm rewriting it pretty often. Can we multiply or divide? In the parenthesis, no. Can we add or subtract in the parenthesis? Yes, 88 minus 15. So that's going to be 8373. There we go. 73 times 2, are there any parentheses exponent? No. Can we multiply or divide? Yes, 73 times 2, 146.
46.
Great. Okay, so these ones, hopefully they're not too complicated. We have 24 plus 600,000 plus 15 billion. So we're going to have 15 billion, comma, and then are there any millions? No. So 0, 100, 0, 10, 0 million. And then here's the 100,000s place. So there are 600,000. 600,000. And then we have 24. So 0 in the 100 place, 24 in the tens and ones place. Next, we have 42 million, 17, and 80,000. So we're going to have 42 million. How many thousand? 80,000. So 0, 100,000, and 80,000. Whoop, 80,000. There we go. And 17. Okay, factors. What does factors mean? Factors are just, if I have the number 42, I'm finding numbers that multiply into 42. And so they want us to check 10 numbers. Can 1 go into 42? Yes, we'll write 1. Can 2 go into 42? 42 is an even number, so we can instantly know it does. So yes, 2 goes into 42. Can 3 go into 42? Yeah, it can. 3 can go in a 30 and a 12, so that would be a 10 and a
yes, it can.
12 would be a 4, so 10 and a 4, so 14 times 3, right? Okay, so 3 goes in. Can a 4 go in? No, it can't, because I could do 4 times 10 is 40, and 40 plus 4 is 44, so it can't go in. So not 4, I'm not going to write 4. I can write a little cross for 4. 5, can 5 go in? Nope, it's not divisible. How can I tell if 5 goes in instantly? If the ones place is a 0 or a 5, then the 5 is divisible by 5. The ones place is not a 0 or 5, so it can't. What about the 6? Ooh, yes, it can. A 6 can go in. Yeah, that's correct. 6 and 7. So I guess that tells us 6 and 7, right? Can 8 go in? No.
Sorry, Mr. Barry.
That's all right.
My
That's all
camera
right.
isn't working.
It's okay. So can 9 go in? No, 9 can't go in. And 10 also cannot go in. So we have 4 factors for 42. At least these are 4 factors out of the first 10 numbers in the
Mr. Barry,
numbers.
you forgot to write 7. Include.
Okay. Great. So these are the first 5 factors of the number 42. Let's look at the number 64 next. Can 1 go in? Of course it can. Can 2 go in? Yes, it's divisible by 2. Can 3 go in? No, 3 cannot go in. Can 4 go in? Yes, 4 can absolutely go into 64. Can 5 go in? No. The ones place is not 0 or 5, so 5 can't go in. Can 6 go in? No, because 6 times 10 is 60. 60 plus 6 is not 64, or it's above it, so we can't do it. Can 7 go in? 7 cannot go in. Yep, absolutely cannot, because 7 times 10 is 70. 70 minus 7 is 63, which, doesn't work. Can 8 go in?
8 can go in.
Yes, 8 can go in, yeah.
8.
Can 9 go in? No. And can 10 go in? No. Great, and so those are our numbers for 64. Those are our factors. At least there are more factors. So for example, like 32 is obviously a factor, right? But we only have to write the first couple. So that's the first page done. Great, let's go on to the next page. Solve. A, 50 songs downloads. 50 song downloads cost $5.50. So how do I write that in a equation? Well, 50 songs, so 50 times some number. Each song costs the same amount, and I don't know how much the song costs, so 50 times, or I could just write the variable right next to it. I'm going to do a lowercase s, and you always want to be careful when you use s's. It's not ideal. I could just write song even if I want. It does not really matter. 50 times song. So why am I writing this? Because 50 times song is equal to $5.50. What does this tell us? Well, each song costs the same amount. And so 50 songs would be 50 times however much a song costs is equal to $5.50. And so it says, how much would 20 downloads cost? Or how much would 20 songs cost? Well, first we need to find out what one song costs. So how can we find out what one song costs looking at this?
$5.50 divided by 50.
Yep, so because we want to get what song is alone. If we get song alone, that tells us what one costs, and once we know what one costs, we can find out what 20 costs. So we're going to divide both sides by 50, and the reason is because we don't want to know what 50 times bigger than a song is. That's what we know already. We already know that 50 songs is $5.50. We want to know what one song is. So how are we going to go ahead and do $5.50 divided by 50? Well, is the 0 going to go away? What do you guys think? Is this 0 going to go away? Well, I know the 5 is going to go in here once, right? And the 5 is going to go in here once. So let's go ahead and try it. We could double check. 1 times 0 is 0. 1 times 5 is 5. What was it? Oh, yeah. 1 times 0 is 0, and then 1 times 5 again. Ooh, that's not gonna be it. We need one more decimal, right? How about we just go ahead and divide it? That's fine. $5.50 divided by 50. Did you guys do this on your paper or no? 50 goes into 5 0 times. 0 times 50 is 0. 5 minus 0 is 5. Drop the 5. 50 goes into 55 one time. 1 times 50 is 50. 55 minus 55, or 55 minus 50 is 5. Drop the 0. 50 goes into 50 one time. 50 times 1 is 50. 50 minus 50 is 0. Decimal goes straight up. Great. So we found out that $5.50 divided by 50 is equal to 11 cents, 1100. So one song is equal to, I could write this as 11 cents, or $0.11, or $1,100, or 11 cents. It's all the same. So a song is equal to 11 cents. So what's the question asking for? Is it asking for how much a song costs? Can we write that down now? No, okay, so it says how much would 20 cost? So all we need to do is find out how much 20 costs. So 20 times, maybe I could do this in a bit less space. 20, oh wow. Here we go. 20 times 1100th. So 0 times everything. 0 times 1 is 0. 0 times 1 is 0. 0 times 0 is 0. Then we're doing a 20 now. So 20, or 2 times 1 is 2. 2 times 1 is 2. 2 times 0 is 0. Add it. 0, 2, 2, 0. And then we have 2 numbers after the decimal, 2 numbers after the decimal. And so that gives us $2.20. So we should definitely include the unit of measurement and a sentence. So 20 song downloads cost and so our unit of measurement in this case is money, $2.20. And remember, always round money to hundredths, as you know, at least in elementary school. So next we have B. Mr. Doe paid a sixth of his $870 salary and taxes and $140 as a loan payment. How much of his salary was left? And so this is the bar graph that we have. We can obviously draw this bar graph ourselves, but the total is, what's the total? Well, the total is going to be his entire salary, $870. and you see the salary split up here, because first of all, a sixth of it was taken away, right? So I'll just use the green to represent a sixth of it. So how can we find out a sixth of $870? How can we find out a sixth, 1/6 of $870? What does 1/6 mean?
Times 1 divided by 6.
Yeah, that's what it means. Absolutely. Another thing that it means is 1/6 means split it into 6 equal parts and you get 1. And so the reason why this math works is because we are doing 870. We're dividing it into 6 equal parts, 870 divided by 6, and then we multiply it by 1. You only get 1 part. So we could go ahead and do our fraction multiplying. So we do the top times the top would be 870. And then the bottom times the bottom, 1 times 6 is 6. And so now we could just do division like normal. Six goes into 8 once. Ooh, this one would be what? 4. And then this would be 5. Great, and so 6 goes into 170, a total of 145 times. And so we wanted to find out what 1/6 of $870 is, and that is $145. So see, I just chose 1, and that's $145. That's the sixth of it. Great, so he spent a sixth of his salary. He spent $145 of his salary in taxes and $140 on a loan payment. So the other one is $140. And then the blue is how much is left. And so we could write a question mark. We can write X. We could write left. It doesn't matter. I could just write X. I'll just write X. And so how do we find out what X is? Well, you guys could probably do it in your brain really easy, but I'm just going to write an equation. Everything on the inside added up is equal to the total. So we'll write $870 is the total is equal to, we don't know how much he has left, so we'll just write X plus he spent $145 plus $140. Why am I adding all these up? Well, because this is how much he started with. He started with $870, and then he spent $145 on taxes, 1/6 of it, and then he spent $140 on a loan payment. And so how can we find X using this equation?
145 plus 140, and then 870 subtract.
Yeah, absolutely. So 145 plus 140, that is going to be 285 plus X is equal to 870. And if we want to find out what X is just some variable, you know, we'll subtract 285 from both. And the reason that works is because we don't want to know, we know that some number, the number that we want, we know the number we want plus $285 is equal to $870. But we don't want to know what, we don't care about $285. So we're subtracting it from both sides, so we only have the X left. 10 minus 5 is 5. This is 8. 8 turns into a 7, makes this 6. 16. This is 8. 7 minus 2 is 5. And so did you guys get $585 left?
Yes.
Good. Okay. That's what I got to then. $585 left. Okay, next. And make sure you have your unit of measurement. So that is a $sign for this one. Tommy owns 450 stamps, which is 1/4 of the amount Henry owns. How much does Henry own? Well, we actually don't need.
A lot of stamps.
We don't need to do too much math for this. I'll draw a bar graph just because why not? We have Tommy and we have Henry. And so Tommy owns 450. I'm not going to draw his yet. Henry owns, if Tommy owns 1/4 of Henry, Henry owns how many times more than Tommy? 4 times more. Right? So look, if I split Henry's into 4, Tommy owns a 4th. And we know that Tommy's is equal to 450 stamps. And so if we want to solve this, we know we can find that Henry's, we want to know how much does Henry own. Henry's going to own 4 times more than Tommy's. So 450 times 4. Great. That shouldn't be too difficult. This could be 1,600 plus 200. So 1,800, is that what you guys got? 1,800 stamps. So remember, you're using a measurement stamps. Dad bought 2 hammers. One cost $28 more than the other. This tells us a lot. This one sentence, one cost $28 more than the other. That means that one is going to be more expensive. So this one's more expensive. And we know that the blue is going to be $28 because that $28 is more than the other one. And then you know what else that tells us? That tells us that these two that we don't know are the same. And if they're the same, then we can use a variable to represent them. I can use X. Or in this case, I'll just use Y. It does not matter. So the reason I'm using Y is because I know that both these numbers, both the numbers in the green are the same number. And so why does this help me? Well, I know that the total cost, the cost of the first hammer and the other hammer, which costs the same except costs an additional $28, I know that total, both of them together, add up to $64. And so how does this help me? Well, I can make an equation with all of this on one side and then the total on the outside. And so that would be $64 is equal to what? What do we put on the other side of the equation? What is everything here?
Equals, I don't know how to say it.
Well, we have 1y and 2y's. 2y's, if we write 2y, what does 2y mean? 2y is
2y.
y plus y. Yeah, there's 2 y's. Y plus y is equal to 2y. There's 2 y's, y plus y. Y times 2 is equal to 2y. And y times 2 is y plus y. Okay, great. And so those are 2 y's out of the way. And then we also have a 28 plus $28. Why does this work? Well, we know that Dad bought 2 hammers. One costed Y, so we have a Y in there. And then the other costed $28 more than Y. That's going to be another Y, 2Y, plus $28. And then we know both of them together, 2Y plus 28, is equal to $64. Great. And so to solve this, how can we solve this? What's the first thing we do?
Subtract 28.
Yep, so we're going to subtract 28 from both sides. And so plus 28 minus 28 is nothing, cancels out. 64 minus 28. 14 minus 8 is going to be 6. 5 minus 2 is 3. And so now we get $36 is equal to 2y. And how can we solve what 1y is now?
Divided by 2.
Because we know that $36 is equal to 2y. That means y, 2 times bigger than y is $36. But we don't want to know what 2 times bigger than y is. So we're going to get rid of this times 2. So the opposite of times 2 is divided by 2. So we're going to do divided by 2 on both sides to get y is equal to 36 divided by 2 is going to be $18. And so what's the question we're trying to answer? The question we're trying to answer is how much did the cheaper hammer cost? And you see the cheaper hammer is the one that's only 1 green block, right? Because the more expensive hammer is the green block plus $28. And so the cheaper hammer is 1y. And we found out that y equals $18. So we can write the cheaper hammer cost $18. Okay, so last thing is the bonus
But
question
you
at
just
the
said
bottom.
class yesterday.
Yep, but the people in the video with Virtual Berry didn't do it, so we're going to do it again. So, who am I? I am lurking between 200 and 300. My ones digit is double my hundreds digit. I'm divisible by 8 and 11. So, we know that the hundreds place is going to be a 2, because it can't be, well, I mean, I guess it could be a 3. No, it can't be 3 because it says between 200 and 300. So I'm going to say that's less than 300. So we know the hundreds place is going to be a 2. And if the hundreds place is a 2, well, it says the ones digit is double my hundreds digit. So double 2 is a 4. And so we know there's going to be a 2 in the hundreds place and a 4 in the ones place. And then finally, we have to find out what is in the tens place that would make the whole number divisible by 8 and 11. And I'm pretty sure that would be a 6. And how would you find that? Last place? Guessing numbers and then testing to see if it works. You only have 10 options, right? 0 through 9, so it wouldn't be terribly hard. You just plug in 10 different values, and one of them is going to work. So great. That is everything you need to know for the whole review. We'll be doing another review later. So yeah.